Good afternoon, everyone.
Hi, good afternoon.
Hello. Okay, welcome to our sessions. The Engineering Education Research session 3.7.3. I'm Kunchini Maniratana from the Faculty of Engineering, Chulalongkorn University, which is assigned to act as your host here. In these sessions, we have a lot of time for 1 hour. And we have only 2 papers, which I think is nice. We can have, let's say, it's a lot of time to discuss. What's happened here is that the session will be the host will show the record of the videos. For this case, it will be no more 10 minutes, and then we will be able to discuss about it later. The first paper will be the paper Building Student Agency Through Online Formative Quizzes by Dr. Louise Pick and Jonathan Cole from the School of Mechanical and Aerospace Engineering, Queen's University, Belfast. So, yes, I think, please.
Hello, my name is Louise Pick. I'm from the School of Mechanical and Aerospace Engineering at Queen's University Belfast. My colleague Jonathan Cole and I would like to present a paper today called Building Student Agency Through Online Formative Quizzes. This presentation will discuss some of the challenges in teaching thermodynamics and fluid mechanics, both generally and at our school. And then I'll look at how we use the introduction of a new virtual learning environment to introduce measures to try and increase student engagement and student agency, and I'll report on some of the results of this. It is well recognised that there are challenges in teaching and learning in the area of thermodynamics and fluid mechanics. They're often regarded as some of the most challenging modules that students will come across during their undergraduate degrees. There are a number of areas that cause problems, but these include things like the fact that students often haven't studied anything in this area before. The subjects tend to be quite conceptual, and this causes problems for students in visualizing what is going on in the problems they are looking at. Sometimes students lack the context to fully understand the issues. It also requires quite strong mathematical skills, especially for fluid mechanics. And it is the type of subject where learning is very incremental. So if students do not understand the material early on, then they find it very difficult to catch up later. So in our own case, our Stage 1 Thermodynamics and Fluid Mechanics module is one of our 4 Stage 1 core modules. And all students across the mechanical, aerospace and product design engineering pathways take this subject. It's compulsory to pass this module in order to progress into Stage 2. Generally, the classes are quite large with over 150 students. They have 3 timetabled hours per week, which include a 2-hour lecture and a 1-hour tutorial. The 1-hour tutorial is generally held with the students spread across some large group workrooms, and they are attended by a lecturer and a few postgraduate demonstrators to help. As you can imagine, with this number of students, there are limitations on the amount of one-to-one help that they can receive. Historically, this module has had high failure rates and low average grades. Understandably, problems arise for students when they're faced with this very new content, taught at the very beginning of their transition to higher education, in a large class where they have limited student-instructor contact time. Encouraging and helping the students to build student agency, which is defined as the capacity to set a goal, reflect and act responsibly to effect change, making responsible decisions and choices, can help students to ensure their own success. This ties closely into the CDIO syllabus section 2.4 on attitudes, thoughts and learning, which emphasises the importance of engineers taking initiative, responsibility, working independently and reflecting on and responding to feedback. When a new virtual learning environment was rolled out across the university in 2019, we saw this as a great opportunity to try and digitally enhance some of the teaching and learning. so that students had more opportunities for active learning, for managing their own learning at their own pace, and also to provide them with feedback. And lots of studies have shown that continuous online assessment can be beneficial for improving summative results later on. So what we decided to do was to use Canvas quizzes. So we designed 7 Canvas quizzes which we spread regularly across the year. Each of these quizzes was based on the previous 2 to 3 weeks lectures. The quizzes were formative. They provided no marks, but we did tell the students at the outset that if they did not pass the quizzes, they would not pass the module. Students had 2 weeks to complete and achieve the pass mark, which was generally quite high, over 80% in most of the quizzes, and they had unlimited attempts to do this. There were a variety of question types used on the quizzes, not just multiple choice. This was to try and allow assessment of a range of skills. We monitored the quizzes and the engagement with them throughout the year, and we compared the outcomes in summative assessment with the previous year. We also gathered some qualitative data from student surveys. We were very pleased with the engagement on the quizzes, which remained quite high across the year. It started at 100% and generally was in the mid to high 90% engagement rate. We had a few which were slightly lower. Quiz 6, for example, happened on a week where there were several summative pieces of work due to be submitted for other modules, and we have attributed this slightly lower 88% engagement to this fact. We also had a slightly lower engagement on quiz 7, but this quiz was due to be submitted the week that the UK had its first full COVID-19 lockdown. So we felt that this was an excellent result despite the circumstances. We then looked at the number of attempts it took students to pass each quiz. Quiz 1 was set intentionally as the easiest quiz with a pass rate of just 60%. And we found that 94% of students passed this quiz first time, and by the second attempt, everyone had passed. On quiz 2, we moved the pass mark to 80%. This time, we found that only 40% of the class passed first time, but that by the second attempt, 72% had passed. The quizzes began to get more difficult as the year went on. We find that quizzes 3 and 6 were very similar in their results. So we had over 90% pass rate by attempt 4 for these 2 quizzes. Quizzes 4 and 7 had over 90% pass rate by attempt 7. Quiz 5 was most definitely the most challenging for students. It took 13 attempts for 90% of the class to reach the pass mark. Despite often taking several attempts to reach the pass mark, we find that a lot of students continued to try to improve their mark even beyond the pass mark, even though there was no credit for the marks that they achieved. And we saw this as a great indicator of student motivation. For example, 50 students took at least 1 extra attempt to improve their score on quiz 1. Quiz 3, which was a quiz on steam tables, showed the highest level of students taking 2 and 3 attempts to improve their score, and this was great practice for them in using the steam tables. The lowest number of students, which was 17 students, took extra attempts on quiz 5, and that's not surprising given that it took so long for so many students to pass that quiz. We think that there's a lot of useful information in the variables behind this, and we want to do some more work in this area to look at the various factors that are involved in making the quiz more difficult than each other and in affecting student motivation for each quiz. We find that introducing the quizzes affected how the students used the VLE. Our module showed much higher levels of participation and page views of the VLE compared to the other core Stage 1 modules. The summative assessment for this module takes the form of 2 20% class tests and a 60% final exam. We find significant increases in the average for all 3 pieces of assessment, and we also find a higher percentage of the class passing the assessment first time this year compared to the previous. We should apply some caution in attributing all of this change to the quizzes alone, but it's clear that they will have had a positive effect. Student feedback on the quizzes was very positive. We received a lot of very good comments from the students on how they enjoyed the quizzes and how they helped them to learn. We also found that overall at the end of the year, the module evaluation scores had increased from 4.5 to 4.7 out of 5 compared to the previous year. In conclusion, we saw excellent levels of engagement with the quizzes. We saw very high motivation levels from students in taking multiple attempts to pass the quizzes and also in striving to improve their score beyond a pass rate. We saw very positive influences on the use of the VLE and on the outcomes from summative assessments. And we also got very good feedback from students on the use of quizzes. After the study was carried out, we found ourselves in the difficult situation caused by the pandemic and a very rapid switch to online learning. And because of the positive experiences that we had using the quizzes in 1920, we decided to trial the quizzes as combined summative formative assessment during 2020. And we had again very positive outcomes from this. There are some changes that need to be made for the year going forward, but this is something that we hope to keep doing beyond the pandemic due to the positive benefits. Thank you for your time.
Thank you very much. I think we have some questions from Dr. Tamal Magalit. You can ask, please.
Sorry, I didn't hear you.
Sorry. Okay, please ask. Please ask the questions. Can you hear me?
Yes.
Yes. Yes, please ask the first questions to the speakers.
Okay, thank you. And it was very interesting and excellent lecture. And I would like to know how did you compare the final results of the course comparing to previous years?
Well, the summative assessment in both years was the same. So both in 2018-19 and 2019-20, both used the same format. So it was 2 class tests and a final exam. And they were run more or less on the same format. Certainly the 2 class tests were the same format as the previous year. The only change was that on the final assessment, which was the exam, because we had gone into lockdown at that stage, there was an open book exam. So that was slightly different from the previous year, but we found that the level of improvement on all 3 pieces of assessment was similar. So regardless of whether we ran it as a class test as we had in the previous years, or whether we had the slight change to the exam on the year that we were studying. So we were just looking at basically the averages and also the percentage of students who passed the test. And we found that all of those were higher for all 3 pieces of assessment.
That's all right. Okay, thank you. There's a question in the chat from Dr. Bunshoy Sapmonchai from Chulalongkorn University. How long a student take for each quiz on average?
That's a good question. There was a big variety. So we did see a difference between students who, the students who were naturally stronger tended to finish the quizzes quite quickly. So maybe could do a quiz in maybe 45 minutes or an hour and achieve a good mark, whereas students who were weaker students and who needed more time at times spent hours and hours on the quizzes because they had unlimited attempts to do it. It wasn't timed, so they could take as much time as they wanted. And I think that was one of the benefits of it, that they had as much time as they needed to go back, to look at their notes again, to check where they'd gone wrong, to look for feedback, maybe even to discuss it with their peers and to learn through the process. I've tried other types of quizzes before where they have been timed, And I think students have found it quite challenging to actually learn much from the timed quizzes, because they're almost in panic mode. You know, they're under quite a lot of stress when they're timed, and they find that they don't retain as much information. Whereas I think with the longer time to think about it and to allow the learning to happen sort of over time really helped. So there was a big variety in the length of time students took. But overall, they had a 2-week period in which to work on the quiz.
Okay, that's very good. Now, Dr. Corinne Stenerup, I think you put hands up, right?
Yeah, I'm Karen Stenerup from the University of Aarhus in Denmark. Thank you, Louise, for a very wonderful job you did there. I was wondering, you said you did some multiple choice quizzes, but you also had some other types of questions. I was wondering if you could elaborate a little bit on that.
Yes, so there was a number of different things. So we had some multiple choice, but we also had some numerical entry questions where they had, you know, they didn't have any options. Basically, they had to do the calculation and enter the result to a certain number of decimal places in order for it to mark correctly. We had some matching activities. We had some written responses, which had to be marked manually. What else did we do? I think that was the main things that we used. So there was a couple of different types, but as I say, matching up different things, and also the numerical responses as well.
So how many questions did you have, and could the students see afterwards, okay, so question 4 and 7 you didn't answer? Did they get this kind of feedback?
Yeah, so they got, on each quiz there was about, now they varied slightly across the quizzes, but probably about 10 questions on each. Some of them were quite long questions, maybe had multi-stages in them. And they afterwards, they knew which questions were wrong. They didn't know the correct answer, but they knew what was wrong, and there was maybe a little bit of feedback to say, go back and look at topic 5 on lecture 2, and then they could go back and check it that way. But they knew where they had gone wrong, but not how.
Any more questions?
I have one more question. So Louise, did they do it in class, or did they do it at home, or did you give them time to do it, or at home?
Yeah,
so whenever they wanted.
Yeah, so they had a 2-week period between the quiz opening and when they had to submit. And as I say, they had multiple attempts, so they could submit it over and over again. And as you can see, they did. So this is one of the challenges when we came this year to try and use it as summative assessment, also as a combined, that we couldn't give them unlimited attempts because you would have everyone getting 100% in the end. So we're going to try and look at more modifications to it this year in terms of how we manage that. But yeah, we intentionally give them time, and it was to allow them to process the information.
Mm-hmm.
Thank you.
Thank you. I think Gareth Thompson has also put his hands up, right? Do you have any questions?
Yeah, just a quick one. I've also been sort of dabbling with these online quizzes and things like that to try and encourage students. And one of the things I've found difficult when doing multiple choice questions, although they're easy in some respects, in that you can identify a correct answer and then you put down some spurious wrong answers. Often thinking up what those wrong answers might be, particularly in a mathematical type subject, which I think it was a sort of thermal fluids type module, can be tricky. Did you just, when you were developing your bogus answers, did you have any sort of strategies to develop sort of meaningful bogus answers, ones where you go, oh well, I know what you've done wrong here to get answer B. You've misplaced a decimal point, or you've not taken account of some efficiency factor or something like that. Were you as sophisticated as that, or did you just go, well, these are other answers that are in the ballpark?
they were developed, but based on experience of what students do wrong. So I suppose, you know, overseeing the same types of questions being answered over and over again, you know that they forget to convert something to this, or they forget to do that. Or so I did try to think about where I know students tend to go wrong. I know that's difficult at times when you've got a lot of questions to go through and a lot of possible ways, and students will always think of ways to do things wrong that you never thought of. But I think, yeah, for the vast majority of the multiple choice ones, I did go through them and try to pinpoint, you know, where they might look up a value wrong, or where they might not do a conversion, or where they might forget about a unit, or and so on. So that they were developed like that. It took a bit of time to do it.
Yeah, that can often take longer than the actual basic question is thinking up meaningful wrong answers.
Yeah, and that's why we didn't use an awful lot of multiple choice. So we did go to the numerical, where they just had to enter a numerical value. But there was multiple choice questions used, and there was good destructors developed in the process.
Yeah. Louise, one more question. Why do you want to use it as a summative assessment as well? Why not just keep it as formative?
Well, I think that this year, the year that just passed, as in the year where we've been all online, I think we felt that it was a lot to, well, there was one reason why this year in particular, normally this module is taught over a full year. And this year we condensed it into one semester because we were hoping to run more practical modules in the second semester, in the hope that things would be more settled in terms of, you know, social distancing and so on. So we had only 12 weeks, and we felt that running 8 quizzes, well, turned into 8 quizzes this year, 8 quizzes plus 2 class tests plus an exam within 12 weeks was just far too much. And we also felt that far too much for the students, and also in terms of marking for staff to try and be able to process all that in 12 weeks was quite intense. And we also got the impression last year, in the first year that it was done, that students felt that they should get a little bit of credit for all the work they'd done for it. And in some ways, I think that is true. They probably put a lot more effort into those quizzes than they do into the 20% class test. And I appreciate that it's sort of that they're preparing for the class test, but at the same time, are we over assessing them if we try to do so much in terms of quizzes and class tests in addition? So I think it was to try and avoid that this year. And I also think there's still merit in using a continuous assessment, but as I say, we still need a way around. What we're considering doing is allowing them to do them next year. The first attempt is the mark that counts, but they have to then redo it and get the 80% pass mark in order to be eligible to receive the marks. So I think that might be the way we go, or some version of that next year. But we're still thinking about it.
Okay. Any more questions? Concerning, this is my questions. Okay, concerning the multiple quizzes, I came across some kind of concept inventory questions for something like fluid mechanics and the thermodynamics a few years back, probably 10 years back, quite a lot, but it was taken down from the web. I cannot remember the right name. Have you ever used that one?
I'm not sure. I know what you're talking about.
I think it's around 10 years back, and they have some kind of platform that's trying to produce some concept inventory questions for basic engineering subjects. I try to use that one, and I think it's quite interesting. But somehow it was the questions was more or less pulled down from the web a few years back. But I still get some literatures that mention that kind of concept inventory let's say, database?
No, I haven't. No, and it's something I mean, I certainly look at it, but it's not something I'm aware of using databases of questions.
Yes. Okay. That I I will try to look at, and I'm not quite sure whether I more or less get that thermodynamics and so on. Okay. Yes. Any more questions? Okay. Then, well, thank you very much.
Thank you.
Now we can go to the next paper. In this case, sorry, it's also about some gamification, and the quiz as well is utilizing gamification in mathematics course for engineers to promote learning. Our speakers will be Tama Marguerite from the Tel Aviv Academic College of Engineering, Tel Aviv University. Yes, please.
Hello, and welcome to our presentation on utilizing gamification in mathematics courses for engineers to promote learning. The presenters are Lior Rosenzweig, Yonut Stanchesko, Mika Gabel, and myself, Tamar Margalit, from Ofeka College of Engineering. Our study is about using Kahoot online quizzes in tertiary mathematics courses studied by first-year engineering students. We wanted to check the effects of using Kahoot on students' engagement and motivation, and whether it enables lecturers to discuss mathematical concepts in a deep and interesting way. We present findings concerning two aspects: students' achievements and students' learning experience. Students' difficulties with learning mathematics courses have been widely reported in the literature. One line of investigation is the correlation between students' positive effect towards learning and their motivation, engagement, achievements, and learning outcomes. One way of increasing students' engagement is through active learning, which is defined by Prince as any instructional method that engages students in the learning process, requires them to do meaningful learning activities, and think about what they are doing. Gamification is one of the ways to achieve active learning, and Kahoot is an example of a new digital technology that can be used to apply gamification in the mathematics classroom. In our paper, we discuss several studies that report the use of Kahoot in mathematics courses, but in this short presentation, I wish to quote Perdue, that stated that she has witnessed the power of Kahoot to transform a class of lifeless students into an excited, energized, motivated group of people competing for mastery of a topic. She recommends the use of Kahoot as a first experience in gamification for lecturers. The study was conducted in 3 mathematics courses: discrete mathematics, linear algebra, and multivariable calculus, taken by first-year students in an engineering college in Israel. Each course was taught by a different lecturer to 2 different groups of students, around 20 to 50 students in each group. In each course, the lecturers used a Kahoot online quiz during a lecture. A few words about Kahoot. Kahoot is a game-based online platform designed for social learning. It consists of quizzes of multiple choice questions and is played by the participants simultaneously and individually via a common screen web browser and mobile phones, tablets, or laptops. We designed the 50 minutes lesson activity of Kahoot. The activity had 2 main goals: a midterm summary of the course, and a quiz with high-level questions that were planned to be included in the midterm exam. Each course was taught to 2 groups of students, and the midterm exams included 2 questions that were taught as follows. In group number 1, question X was discussed during the Kahoot lesson, and question Y was taught in a traditional frontal lesson. In group number 2, it was the opposite. In this presentation, I will focus on discrete mathematics course, which studies discrete mathematical structures and includes topics from logic, set theory, combinatorics, and graph theory. The Kahoot activity included 16 questions. Here are the X and Y questions. Both questions require an understanding of definitions of set theory concepts and connecting definition of concepts that do not explicitly appear in the question. Here are the correct answers. And this is what we found. The first table presents the overall students' achievements in the Kahoot quiz in discrete mathematics course. The second table presents the findings for questions X and Y. The correct answer appears in bold. It demonstrated the low success rate of the students in the two groups. In both classes, a detailed explanation of how to solve the questions was given. Thus, the Kahoot activity enabled teaching new implementation and connections of math concepts in an innovative and engaging way. This table summarized the midterm exam achievements. We defined success if the student's grade was at least 70. The findings indicate that in group number 1, the success rates were significantly higher for the question that was solved in a traditional lesson, whereas in group number 2, there was no difference. After the Kahoot lessons, we administered students' feedback questionnaires in order to examine their learning experience. We considered all of the questionnaires as a one set of data, since they do not relate to mathematical content. The most relevant questions for feedback are questions number 3 and 4. We asked the students to rank the value of different aspects of the Kahoot activity, which are listed here. For example, the use of technology for teaching and learning, and the use of Kahoot as means to develop an analytical thinking and increase motivation. The table presents findings from 51 students who answered the question. The most frequent answer appears in bold. As can be seen here in the table, the most popular answer to all 7 questions were by far number 1 and number 2. In other words, the students' experience was a highly positive one. We also asked an open question, in which we asked students to comment on the use of the Kahoot quiz in the lesson. 24 students answered the open questions. The table presents our findings according to 6 different themes we defined. For example, students say that the use of Kahoot is a good way to summarize material, breaks routine, fun, refreshing. It creates positive atmosphere in class. It motivates learning at class and at home. They also suggested improvements, such as to publish a complete and formal solution of the answers. To summarize, our findings indicate that the use of Kahoot quizzes did not have a positive effect nor a negative effect on students' achievements in the midterm exam in any of the 3 courses. Regarding students' learning experience, the use of Kahoot has a positive effect on the learning experience of students and on their motivation, enjoyment, and engagement in agreement with the current literature. Considering the lecturers utilized the Kahoot quizzes also as a way to introduce non-routine and advanced questions to the students, and that one of the experimenting lecturers reported that the use of the Kahoot quiz was less time-consuming than discussing the same content in a traditional front-end lectures, it seems that teaching via Kahoot is at least as effective as the traditional frontal manner. Another point is that some students found that the time limitation in Kahoot is stressful. Yet, our Kahoot data indicated that students' average answering time was less than the time limitation for each question. This phenomenon may be of interest for further investigation. For example, one may investigate if canceling the time limitations affects students' success. One interesting
suggestion that was raised by the student is to announce in advance that a Kahoot activity will take place so that students will be able to prepare themselves to the lesson. This suggestion indicates that the students possibly recognize the potential of the Kahoot activity as a learning aid and wish to make a better use of its offerings. Another interesting student observation is that the Kahoot activity is less relevant for learning proofs and practicing the formal way of writing a full solution to a problem. This observation motivates a future research direction, examining what type of mathematical content, methods, and techniques are best supported by the use of Kahoot. Finally, we suggest that using online platforms such as Kahoot is a convenient and effective way to foster various types of interactions and group activities, thus engage students in learning during a synchronized online lesson. Since online courses are becoming more and more prevalent, we recommend future research concerning the effects of using Kahoot in online lessons. We conclude that the use of Kahoot quiz is indeed an innovative way of triggering deep mathematical discussions in the mathematics classroom in tertiary level, providing that the lecturers who use it succeed in creating an appropriate students' attitude and norms during lessons where these online quizzes are used. Thank you. We hope you enjoyed our presentation.
Okay. Thank you very much. That's very interesting. Okay, yes, we have one hands up from, sorry, the name was, sorry, I can't see. Oh, yes, Emmanuel Delucci, please.
I actually was just clapping my hands to thank the speaker.
Okay.
But I see Karin has a question, however.
Okay, we have some other guys clapping as well. Okay, we have hands up from Karin Stenderup, please.
Hi, Tamar. Thank you for a very beautiful presentation. I was wondering, this Kahoot, do the students do it individually or can they work on it in groups?
They can work in groups. We let them the freedom how to do it. So in several classes, they were sitting and do it with the person, with the student to sit near themselves. And most of them are doing that separately.
Oops, we have to, yes, sorry.
Yeah,
Yes, Emmanuel Delucci, please, you have hands up now.
Yes, sorry, now I have. This may be just me not completely getting what you said, but just, joining the previous question. So you presented a little bit this interface, this Kahoot thing. I wondered if you can expand a little bit more on the game aspect on it. I mean, for me, game implies, strategy or maybe against somebody, or of course it fosters cooperation. So can you maybe say a little bit more explicitly what's the game?
Yes. Are you familiar with Kahoot?
No.
Okay. So
I'm sorry. If this is my problem, I will go and familiarize.
No. Yes, I have a slide that I omitted from the presentation, but maybe I will share it while I'm talking. Just a moment. I'll try to do it. And maybe it will help. Okay. So in advance, the teacher prepares the quizzes and he sets a maximum time limit for each question. The maximum time is 2 minutes, and it can be also 30 minutes, 1 minute, 30 seconds, 2 minutes, and 30 seconds. That's the And at the beginning, all the players are connected to the game. They are connecting with the smartphone, tablet, any device that they have. And the questions are displayed on the screen, and each question is displayed, and we use it as a multiple question, but there are other types of questions. And the players have a limited time according to the maximum time the teacher set in advance. So they need to answer it. And there is a clock and they show the time limitation. So this is the game. It's a competition and the score is given according to correctness and according to the speed, how fast you answer the question. Yes, so this is the tricky points because sometimes the students want to win, so they guess the answer or just enter it very quick. So, okay, that's the time limitation that I referred in the question. And after all the players answer the question, all the time runs out, the application reveals the right answers. And the teacher can stop, he can explain the wrong answer, he can explain the right answer, the students, it enables a discussion at class because we did it 2 years ago before the lockdown. So all the students were in class and they can ask questions, and when the teacher decides, you move to the second question, etc. And at the end, there is a screen where there is the winner and there is some music, and so there is music also, and it's an option, you can choose it or not. So there are several elements of the game, like the music, like the competition, like the prize in the end. Usually sometimes we give some little things to the winner and something like this.
I understand, yes. If I may I a short remark, because I mean I find this interesting, as maybe remarking on your observation on you know, possible ways to treat not only the kind of computational questions but more conceptual math somehow ways of thinking. So I have made not bad experience with the following idea of a game. I mean, you find some kind of game which is an actual game, like, I don't know, tic-tac-toe, stupid example, but you know, an actual strategy game, and to find the strategy or to prove that the strategy exists or that it doesn't exist or who should begin. You know, for certain games, this kind of consideration can be are solved with some mathematical, say, you know, let's say conceptual things, right? So that acts as a motivator. In this case, game is the point of start and acts as a motivator. And sometimes you get to these kind of very serious and formally correct concepts, I don't know, like mathematical induction or whatever, right? Or even continuity of functions without epsilons and deltas and, you know, so I mean, this just as an observation. Anyway, sorry. Thank you for the answer.
Thank you.
Okay.
Tamar, could you elaborate on why do you think that it didn't affect the achievements of the students? I would think it would have a positive impact.
So why do I think that the achievement?
Yeah, you said it had a positive effect on their experience of the learning, but not on their achievement, the final goal. I'm just wondering, why do you think that is?
Why do I think that there is a difference between there's no correlation?
No, you said you showed that the students' achievement was not improved by using the quizzes. Yes. And I'm just wondering, why do you think it is? I thought it might have a positive effect.
And I think that the questions that we asked were they were high-level questions, and usually these courses are difficult courses for students. They are first year students, and the achievements are generally not so good. So I think that the point is that in the Kahoot lesson, we had different questions in different levels. And the questions that we chose to check were the more complicated ones. So I think that's mainly the reason. And there is another reason that I mentioned it shortly. We didn't inform them in advance that we are going to do a Kahoot lesson. And of course, we didn't say that some of the questions will appear in the exam. And we found that the Kahoot lesson, they didn't take notes and they didn't write any explanations. And so I was not surprised that the students learned or saw this question in the Kahoot lesson didn't answer the question. I was more surprised that the students who learned in the class didn't success. And so my explanation is that because those were quite difficult questions.
Do you hear me?
Sorry, Louise Pick, your hands up, please.
Yeah, I just really have a comment more than anything. So I think that was a really interesting presentation, Tamar, particularly that you've done the analysis on this. Because I've used Kahoot in the past and I haven't really looked at the data in detail, but I always had the feeling of what you found was that the students really enjoy the Kahoot quizzes and they're good fun and they bring a bit of energy to the class. But I always felt that they weren't really learning more from them than if I hadn't used them. And I think it's just what you exactly just said, that they're not taking notes, they're not thinking about it. And I'm glad to see that you've had the same experience that I had with it, because I felt that previously I was perhaps using it wrong. But I think it's good to see that. I think for some subjects it might be really useful. I think for the likes of mathematics, where you're having to work through a calculation or you've got to write things down and really process it, I think they find it difficult to get more learning from that. But at the same time, anything to engage the students is great as well. So if it makes them come to class because it's fun, then that's a positive as well. So I just wanted to agree with what you said.
Yes, and we did it in 3 courses, and the results were more or less the same. But in one course, in linear algebra, there was some more evidence that they didn't success more in solving the questions. But the lecturer in that course note that it takes in the same time to teach the material via the Kahoot lesson and via the Fonda lesson. So this is an advantage. I see that Isabel has a question. Yes?
Yeah. Yeah.
And did you examine if there was a gender effect on achievement? We made a research about flipped classroom, and we observed a wider effect on female students. Now, we didn't check it, and we didn't check it. It may be interesting to check it. In the Kahoot lesson, everyone can connect with it. There's no obligation to connect with your surname. So I don't have now data with a female. It's an interesting point. What did you found?
Sorry, I don't think.
Isabel, we can't hear
Isabel,
you.
we cannot hear you.
Is it okay now?
Yes.
Yeah, it's better now.
Yes, okay. So we show that there was an effect on females and not for male. So you don't see effect for the whole population of students, but maybe there is something, because in our studies there was no significant effect of flipped classroom in math, but there was an effect if we examine only female students or students who are far students that was less less good in maths. So there was an effect that was very wider. And I think maybe there is something with this gamification. In addition, there are many studies about gender that shows that female students that are in competitive setting have not the same behavior. So maybe it could be interesting to examine this.
Mm.
That was a remark. Maybe something to do.
Actually, I would like to add my own experience. In this case, for the Kahoot, I don't know, but I usually employ it every week. I don't know whether it helps students or not, but the student says that it's one of the strategies that make them more or less revise up the content, let's say, continuously. Then you leave it until just before the exam. So I think it might help the students more or less as a nudging activities that cause them to be more alert.
I'm not sure that I understand.
Sorry, so any more questions? No. Okay, so I think I'm sure that we will have a chance to talk again if you wish. Anyway, I would like us all to clap for our two excellent speakers. And our session was supposed to end at 2:30, but I think this is nice time to have a little break before the next sessions. Okay, thank you very much, everyone. See you again.
You all.
Thank you. Bye.